So we have finally managed to get our hands on an InfoDrainage license. Shout out to Samir Mohandes who made this happen. And in this video, we're gonna go through what InfoDrainage has to offer. So we're not gonna go into too much depth of everything and break down everything. It's just to give you a quick overview, like what is included in it, what you can do and cannot do, so you can have a better understanding if you're thinking of upgrading from MicroDrainage, for example. So without further ado, let's begin. So to start, let's start from the beginning, obviously. Let's go through the user interface. So we have our menu tabs at the top. So you've got the file, plan, import, rainfall, pollutants, preliminary sizing, build, analysis, results, export views, and help. Now I proved that I can read, but let's go and have a more in-depth look into them. So in the file, you've got the classic files and you've got preferences, etc. We're not going to dive into too much depth. In the plan, you've got your tools to navigate around. So just to show you that you've got the select, so we can select our items and you can see the properties panel pops up, which we'll visit in a moment. And then we can move our mouse by holding the middle click or just selecting the pan option. And then you've got the view extents. So similar to AutoCAD, the double click with the middle mouse, but I do not believe this works here. Nope, it doesn't. So you have to click view extents. And the new feature, which I haven't seen anywhere, might just oversight of mine, is bookmarks. So if I zoom on this pond here and go bookmarks, and I already created one, and just go pond and hit add. If I go, let's say I'm here and I want to visit my pond, I just go select the pond and go to, it will take me to the pond. I can see how this can be useful for massive residential sites. So if you have different parcels, so that could be helpful. So instead of like spending hours of trying to find where the issue is, if you have bookmarked it correctly. Then we have the import tab. Here you can import anything you can imagine. As far as I'm concerned, everything is covered. For the surfaces, we can import CSVs, CAD files, XYZ, land XML files for Civil 3D, and we've got two file formats that I have not seen before, ASC and PWF. And also you can import from manholes. I haven't tested that one. And you can import from other InfoDrainage files. Now, if we go to the tree view, which I'll show you in a second, you can see how this makes sense. And you can see when in my case, I imported a CAD file, it picked up all the points and added them into this elevations point table. Importing a CAD is pretty straightforward. You load your file and you go through the settings. I'm not gonna do this now because I already have imported it. You can import shape files, personal geodatabase files as well, and images, and also TIFF images, which can be used for height recognition. I think QGIS uses them. We can also import from MicroDrainage, so it's backwards compatible. We can import pipe networks from land XML files, which I believe they are the Civil 3D files, and we can import from CAD junctions. Now, I have not tested this one, and I'm really curious to test this one. So I will do some rigorous research on the background and get back to you with a fresh tutorial. And then we can import from GIS, same as the CAD, and from text. So all this probably will fall under 3 separate tutorials. Then in the rainfall and pollutants tab, we have simulation criteria. So if I click on FSR, you can see that it will create an FSR, and you can see there is a parameters, and our old classic map from MicroDrainage is back here. And you can see I can click on this overall map and then click on the city that I'm working with. And we also have Ireland. Then we can add our return periods and our storm durations. Now this can be accessed from the tree view, which is basically similar to Civil's 3D tools panel where you have your surfaces and corridors. So it's pretty familiar structure. So if I right click on rainfall manager and go edit, you can see that in my rainfalls, we've got design storms, and if I expand, we've got the FSR, and if I expand it, I've created the storm FSR, which has the parameters, the return periods that I want, and storm durations. As you know, we have to take in consideration climate change, or if we work with FEH data, we need to load the FEH data. InfoDrainage gives you the ability to save the rainfall manager, so we can import from a different file. So you can see here I created a quick example, rainfalls. We've got Council A FSR, for example, or Council A, and you can see us, for example, load. So if you're a big consultancy, you can create one file with loads of storm, for example, Birmingham Council climate change return periods, etc., or Birmingham Council FEH data in there, and load them into one file, and therefore your team doesn't have to recreate it. That's very beautiful. And then we've got the storm duration, and we can can click rainfall viewer, we can see our rainfall, and we can select the storm, and you can see how it actually looks like. Then we have the pollutants in the rainfall pollutants. This is a feature I haven't seen before. Basically, you can add pollutants, and then later on you can run a flash flood analysis and say, okay, from that area, how much pollutants were concentrated, and you can prove that the SUDS is working or whatsoever. I haven't tested this, so I will have to do some training probably with Summer to understand how this works, so I can create a tutorial for you guys. Then we've got the preliminary sizing. So we've got the deluge, which is, or delage, I don't know how you pronounce it, I'm not French. It's the blue and green corridors. So basically, if we go deluge, you can see we can select the manning. So if it's urban, rural, in my case is rural, and I can select the area, starting depth of the water basically, and the analysis time 60 minutes. So if I do, let's say 100 mil and hit OK, it will build the mesh. Now nothing appeared on my screen. That's because it's in the tree view. If I go to tree view, to the analysis, expand it, view 2D as deluge, and click on the depth and flow directions and the legend as well, so I can understand this better, you can see that wherever is blue, let me untick the surface first so I can see better. So you can see blue is depth of 0, and then when it becomes cyan is depth of 0.375. So that is basically where water gets concentrated. You can see even the arrows, the flow directions point to that a low spot, if you see here. So the lower the spot, the higher the depth is. So you can see on your existing surface, you can see where the water is going, and you can model it accordingly, or you want to prove something to the LLFA. We've all been there. So I'm gonna tick the to the analysis and tick again the surfaces. So that's deluge. And in the connections, it's basically a table of all your pipes or the flow paths that you define. That's a new feature I haven't seen else before. I'm not sure if I'm a big fan of it, but I think I just need to use it more and more so I can understand it better. So flow path, basically, it allows you to define a route or route. I don't know which is the correct pronunciation. So I've defined this flow path route, and you can define multiple ones and you can view them, or you can view all connections. And here you basically view your pipe. So basically is your, think of it as your Excel table that you work with your data. For example, pipe number 1, I don't want it to be a pipe, I want it to be a rectangular channel, and you can modify there. I don't want the slope to be 1 in 42. Now I've tested this on 2 jobs. I did not have to use this because I'm a big fan of using everything from the properties panel. So I'll show you in a bit on how I do that. Let's finish the preliminary sizing. Then we've got the network design criteria. Now here you can see that how do you want to size our drainage network. So we can use the UK modified rationale method or the rational method. So you can see here we can select from which storm we want to optimize or design our network. It will be storm FSR, and then it will show us the properties and which return period we want. Now we specified the 1 year. We can add more return periods if we need, time of entry, and maximum travel time. And then we have design options, which probably you'll be interested in these. You've got the pipe size default library. If I click on this box, you can see I change it. Usually it's 100 and 150. I want to start from 150, and you can see I can define minimum and maximum slopes, which is great because then I can cap it and I can know, okay, that is the flattest I can go with the 2 to 5, which I believe is 167.5. And I think this one probably 100, let's say. I think that gives you a velocity of 1 meters per second. And please review highlighted 1 or more entries. Let's see. Maximum values must be greater or equal to the minimum values. Okay, so let's add a minimum value. Oh, max slope is the steepest. Apologies. It's the other way around. 167.5 and 100. And okay. Then we have some level design options. So we can design level to soffit, level to invert. We want soffit to soffit. Minimum cover depth, we can specify 1.2 standard. And we can specify the minimum and maximum slopes. Then you can see that we have the manholes now. So if I click on the box again, you can see that we've got diameter width, connection 0 millimeters, 1.2. If it's 375 pipe, 1350. If it's 500, 1500. So they predefined it. You can predefine yourself. And also you've got some additional sizing options. Then the depth, you can specify, for example, if the depth is 1.5, then 1.2 diameter. So the depth is basically define the manhole depth. So not only the pipes, but also the depths can specify the diameter of a manhole. Then we've got the axis, and this is for lateral protrusions, which I haven't seen before. Maybe will come in handy later on if we can export this information. But for the purpose of the simulation analysis, I haven't touched it. And then we've got the backdrops, check for velocities, and some other information that we'll cover in a separate detailed tutorial. Then we've got the network design wizard, which takes into account all the previous stuff that we've done. So we do the flow path, which I told you that you can define flow paths, and we can see that you can select the design criteria. So you've got the flow path, so basically the route that we have predefined, and then we have design criteria for the storm that we need to design to, and then we have the design options for the pipes and manholes and backdrops and velocities and levels. And if we hit next, it tells us, hey, for the pipes, these are the settings that we're changing, and for the manholes, there's no changes. And if I hit finish, it applies the changes and shows me a summary report, which if I close it, can be accessed from the network design report. Now, size inlets, sizes the capacity of the inlet. I have not tested it. I'll have to speak with Summer and understand it fully because I haven't seen it in other softwares. Then we've got the quick storage estimate, our classic. So you can see we've got user input or use planned data. So basically we can say, for example, hey, 2 liters, no infiltration, calculate, that's it. Or we can input everything manually. So that's the area, that's the volumetric runoff, and that's the discharge rate. And we want to calculate quickly, or we want to see graphs as well. Usually it's quickly is enough. And you can select which storm you want. And then we've got the runoff. So in the runoff, we have our different methods of calculating the runoff. So we have the ICP SUDS or IH124, which is interesting because the IH124, if you know, it basically we need to put an area of 50 hectares and then interpolate it. So basically if our site is 10 hectares, okay, 10 divided by 50 and then get the Q-bar accordingly based on that. There's a whole document that explains you how to do it. But it says here that the ICP SUDS method will do this automatically. So I would use ICP so it can do it automatically. And then we've got area SAR, which can get from the map, and then the region again from the map. That's beautiful, they show it. And then the additional options, which is a beautiful thing, is that now we can calculate the return period for a specific year. So now we want the 25, for example, or the 50, and hit calculate. You can see we've got the Q bar, the 50, and then 130 and 100, the standard ones. And then the greenfield volume calculator, which basically will calculate the volume of runoff if you're using long-term storage, so you can prove that you provided the storage, immediate storage and long-term storage accordingly. Then we've got the water quality volume. So we can specify 2 methods, the simple water quality volume and runoff reduction. I have to do some digging on this one. And then again, user plan data or user input. And you can see that the precipitation depth, let's say first 5 millimeters, or we can put 0 for now. And if you hit calculate, it tells you target volume 0, achieved volume 416, untreated volume 0. Outcome success. Not sure how that is success, but probably is because we have a pond in our system and applies towards the water quality. Then we have the first flush, and you can see that here we added the pollutant A, if you remember, from our rainfall and pollutants, and we can see it here, and it says concentration. So if we do rainfall depth of 75 and we did calculate pollutant A is 0 because we didn't specify the milligrams per liter. So if we do 1 you can see that the pollutant load is 0.26. So that will be very helpful for those who are going in detail into improving the water quality. I haven't had to do this before, so I understand I will have to do some studying and bring you a full tutorial on it. Then we have the build. Here we have everything that you need to build your drainage network. So we've got the base flow, catchment area, green roof. So basically anything that water needs to go into. So basically we can do it based on a base, catchment area, green roof, or hydrographs. And we've got the junctions, basically all the nodes. And then we've got all the SUDS features, bioretention, cellular storage, chamber. And I would like to stress out that they've done something very beautiful here. So if I go to the tank, and let's say we're going to put a tank here, you can see now I can actually define a tank. And okay, I did the shaping wrongly, but let's go to plan, select our mouse, and you can see I can rotate it. Now you can see the arrows showing how the tank is flowing, which is beautiful because now I can actually see exactly how the tank is. So I can define it exactly how I needed it to be. And that applies for the soakaways, for the swales. I haven't tested for Peros paving works as well. I've tested that one as well. Then we've got connection inflow. So if I want to connect this surface again to here, you can see this beautiful pop-up that says, is it a new connection or is it an inlet? It's an inlet in my case. Then we can add connections. You can see here I've got different types, bypass connections and curves as well. Then we have the add network. Basically, this is all this on steroids. That's the simple way to put it. So if I click add network, you can see I can start drawing and adding. And if I hit escape, you can see it designed the manhole pipe, and so on, so on. So if I click add network, you can see that it says next item. I don't want it to be a manhole. I want to be a sealed manhole. So you can change that. So you can see, you can go right click as well and change it from there. And then let's say now we want to do a standard manhole, and now we want to do a box culvert, and then select so we can finish. So you can see here it says box culvert. We just have to define it. But yeah, and you can grab those nodes and move them around, similar to the draw net of MicroDrainage. So then we've got the add train. So basically that continues. So you can see it highlights and you can continue your network. And you can see in the tree view, these kept expanding and updating. And I'm going to minimize the junctions for now. And the flow paths, you can see that's our first flow route. And we've got our first train, our second train, and then the third train that we've created. We can rename them by just right clicking rename. And for example, we can name it main route, so we can identify it easier. And we can add a flow path manually by specifying, okay, I click on it, I want from here to there to be a single flow path by itself. And you can see it creates a flow path here. And then we have the data tab. So we've got the connections. So you can see all the connections and you can flick through the flow paths. And then we've got the tables that we can create custom tables. So this is all, and we have the flow path, and we can tick and untick what we want to show. So depth option, I don't want to show. And we can save this configuration to use in the future. And we can also highlight manholes just to know, for example, okay, this is my hydro brake here, for example. So keep an eye on this one, and we can just have this on a separate window, that's the beauty of it, because I can keep working on this on the background and have this table open at the same time. So if you're working on two screens, that's a winner. Then we've got the show profile, which they invested a lot, what I would say, in the graphics and understanding of how everything looks. So you can see that's my hydro brick there, that's my pond, and we've got our pipes. You can see this pipe's above the ground, so probably I will have to do something about it. But yeah, and there is loads of options. You can export to CAD as well, or export the image, or change some CAD options. So when you export into CAD, and plot current flow path, so you can actually print it or PDF it, if you may, straight away from InfoDrainage. Then we've got our analysis. So analysis criteria, we select from the rainfall managers that we've created. The output interval is 1. So basically that is the step. So if we have a 30-minute storm, it's every 1 minute we want to see what's happening, or every 5, for example. Then we've got the time step, which can be default. And if you have some instabilities, you can change it to reduced or shortest. Then we've got the urban creep and perform no discharge analysis. I think that's the flash flood, which I have to do some digging for it. So apologies, I wasn't aware of it. Then we've got the summary of the method we're using, FSR, number of storms 72, and the maximum runtime. So if I hit OK, and if I go validate, you can see that I don't have any issues, everything is okay. And if we hit go, the classic go icon stayed with InfoDrainage. It was from MicroDrainage, I believe, and it stayed with it. Does it perform analysis? I believe they're using the swim engine, so that is good. So you can see that now we have our stormwater control summary. If I go critical storm, you can see that the critical storm is the 100-year 40% percentage available. That's a beautiful thing because it tells you percentage available. Now you have to bear in mind, I didn't produce a reasonable network, so the -15 should be reflecting something. Is the pond not utilized enough, or it's actually overutilized? I believe when I've run it on the previous live job, it would tell me, for example, percentage available 3%, like it's still available in the pond and I could reduce it. So now if we go to the results window, you can see we've got the inflow summary. So you can see that parcel A and parcel B, which I've created the catchments, the areas. So basically that's all the areas I've created, and they're here. So that's parcel A and parcel B. You can rename them from the tree view. And then we've got the manhole schedule in the results. So you can see all the manholes. We've got takeoff data, which I'm not going to go into. And then in the summaries, let's look at the junctions. So if I go critical storm, you can see that we've got some flooding in S1 and some flooding in S3. Now, I want to see how it's flooding. You can see as soon as you're on the results, we have the play controller at the bottom. So if I select the correct storm. So let's go have a look again. So critical storm, it's the 100-year 15 winter. So let's scroll down. And if I hit play, you can see that it shows red where it's flooding. But a better view we get in the 3D view. So if we zoom in and hit the play button, you can see that we can see the flooding. Let's untick the surfaces just for make it easier to the eye. We can see the flooding now, and you can see that the 3D view is way better than what MicroDrainage was doing. So that's the pond. The beauty of this is that after you finish running your results, you can also do a analysis, a 1D, 2D analysis, and we can do it based on the storm that we want to see where the actual flooding is going. So we're going to do it every 2 square meters, and if I hit OK, that will take maybe a few seconds. And you can see it shows the summary, and I want to see mainly the 2D analysis ticket, and make sure you change to 1D, 2D deluge. And I'm going to bring the surface as well just to see what's happening. And you can see that actually it shows you where the water actually would go. So if I hit play, shows me where the water will go. So that is a very great feature to have, and we can go back and argue with the LLFAs if we have any issues. And then in the export, we've got to CAD image. We can plot profiles, which can be accessed from the show profile. Pipe networks, we can export them into Civil 3D, so we can import them into Civil 3D. That is a total beast by itself. We'll have to look at it. And we've got some other export options. And in the views, so it says here change layout, so you can do basic drafting. So you can have the tree view, toolbox and properties, and also you've got the 3D view at the bottom. If you want to see it at the same time, you just drag out at the moment, and then if you cannot see the menu, just resize it, and then I want to dock it there, so you can have the 2D and 3D next to each other. And also you can undock it and have it on a separate window by itself, so you can view it, so you can work on multiple screens if that's what you like. Then we've got the tree view. Everything we went through the menu at the top can be accessed also at the bottom. The checkboxes act as layers turning on and off. You can see that we can turn off the connections as well, and you can see only the pipes, and therefore I believe you can export only the manholes. Now in the display settings, you can change everything, and you can have also import and export styles. We've got settings for the layers, the surfaces, how the surface should be presented, for the 2D analysis, so the deluge, the plan, like the text and everything, properties for the profile, and these are the additional for the flow paths, and then this is for 3D. And then some annotations. So for example, if we wanted the junctions manholes to show the type, I hit apply all, it tells me it's a manhole. Same works for the inflows. So we want to the connections, the pipes. Want to show the slope, upstream invert, downstream invert, and then we can show like length, etc. And we can export them into CAD accordingly. And then we have the help, which I used quite a lot just to get my head around the new features that I couldn't get from the get-go intuitively. But yeah, let me know what you think. Would you transition from MicroDrainage to InfoDrainage? My personal view is it's a great software to transition. So if you liked this video, hit the like button. If you loved it, hit the subscribe. And if you could kindly share this video with other civil engineers, so if they're thinking of purchasing InfoDrainage, that will give them a little bit of insight. Now, more tutorials will follow. So the idea is to break each element of InfoDrainage individually and focus on it to the full detail, and then do a few exercises of modeling a full network and what to be careful of or pay attention to. And I'll see you in the next tutorial.